Hello, and welcome back to the official podcast of the 2024 International Fuel Ethanol Workshop and Expo, or FEW. I'm your host, Danielle Piekarski, and I am joined today by Chuck Gallop, Director of Innovation at ICM Inc. Chuck will actually be presenting twice at FEW, once in Track 3 at 1 p.m. on Tuesday, June 11th. His second presentation, which we will be discussing today, is a part of a panel titled Technologies Enabling Low Carbon Ethanol Production Throughout the Production Process 2. This panel will take place in Track 2 at 3 p.m. on Tuesday, June 11th, and Chuck's presentation will focus specifically on electrifying your ethanol plant for carbon savings. Welcome to the podcast, Chuck. Thank you for joining us today.
Thank you very much, Daniel. I really appreciate the opportunity to join you and talk with everybody out there and invite them to the Fuel Ethanol Workshop. We're pretty excited about this year's panels that are going on. There's a lot of information to share this year, and we're pretty excited about it. So thank you.
Of course. So of that information that we have to share, can we start by just having you tell listeners about yourself and what ICM does as a company?
Absolutely. Good afternoon. My name is Chuck Gallop. I'm the Director of Innovation for ICM. This role is responsible for creating new technologies and products and processes from ideation through commercialization. It's a pretty important role within ICM, and we work closely with all areas of ICM, including engineering and project management and research and development. Now, many of you know that ICM has been in the ethanol industry for more than 25 years and responsible for the design of more than 70% of the ethanol plants in North America, and more than 30% of all of the ethanol produced globally. So we take this industry very seriously, and we look forward to working with you and your plant on new technologies.
Thank you, Chuck. So one of the things that you will be focusing on in your presentation is the Inflation Reduction Act, which has greatly impacted our industry. What are some of the key ways that the Inflation Reduction Act, or the IRA, incentivizes ethanol producers to lower carbon intensity scores, and what benefits can they expect to see from doing so?
That's a great question. How can the Inflation Reduction Act help the ethanol producer, and what incentives are there really for that? This is a legislation that's really has the bookmarks to it, but it's still really being framed out by our legislators. So it's really still under development on how it will work and how the plants that take advantage of the Inflation Reduction Act are really compensated in terms of these types of efforts put forth by the plant. So really what the Inflation Reduction Act wants to do for us is to reduce the carbon intensity at the plant, and that can be done a number of ways. One really important way that you hear about is carbon capture and sequestration. And so that's where you're taking the CO2 produced from fermentation and you clean it up and you put it into a transport pipeline, and then it's sequestered into a geological formation underground permanently. Other ways at which we can do this is reduce the amount of natural gas that is used in the process, either through producing steam or drying distillers' grain products or distillation. And then there's really another way that we want to focus on today, and that is really exchanging natural gas consumption for electrical use. And so we really want to talk about ways at which you can electrify your plant to reduce natural gas consumption.
Okay, so what are some of the applications that demonstrate how an ethanol facility can recycle their waste heat to improve their efficiency while also displacing the use of natural gas?
That's a great question. So there are a couple different ways at which a facility can recycle waste heat. And when you take a look at a vacuum distillation system, one of the benefits of that system is that once the product is vaporized, whether it's the ethanol or water from evaporation, it maintains a vapor state all the way through distillation or all the way through evaporation. And that happens through vacuum. So the energy is used over and over through multiple evaporators or through multiple distillation columns. And this reduces the amount of energy that is wasted to the cooling tower, and then that liquid have to be reboiled. So having a vacuum distillation is one way to reduce energy. Having multiple effect evaporators in series is another way. Another way at which you can do it is by optimizing your whole stillage decanters to produce a much drier cake. This reduces the amount of water that is presented to the dryer, and we can reduce the amount of natural gas that's used to dry that cake.
Very interesting. Okay, so one last question for you here, Chuck. What type of process solutions is ICM currently working on, and how do the technologies that you covered in your last answer play a role in any of these developments?
So one of the new developments that ICM is working on is a way in which we can recapture wasted energy to the cooling tower and cycle that energy up to a usable form within the plant. When we consider that the corn coming into the ethanol plant is at ambient temperature, the water coming into the ethanol plant is at ambient temperature, and that the ethanol leaving the ethanol plant is at ambient temperature, this implies that nearly all of the energy produced by the boiler leaves the plant through the cooling tower. Not only does the energy produced by the boiler essentially leave the plant through the cooling tower, but all of the heat generated during fermentation will leave the plant via the cooling tower. ICM has developed a technology to capture that energy from the cooling tower return water, cycle that energy up to a usable form in which we can generate low pressure steam for use in evaporation and distillation and slurry and other low pressure areas throughout the plant. But not only that, we can use that same energy to offset natural gas use at the dryers. Currently, there's nothing out there that allows this to happen. So that energy is typically wasted through the cooling tower to the atmosphere. We're pretty excited about this technology. Now, it does reduce natural gas use, and it's electrically driven technology, but it's able to pull that energy out of the cooling tower water and cycle it up to where we can produce steam for production and reduce natural gas at the dryers.
Great. A two birds with one stone approach. Well, Chuck, we are coming near the end of our time here. Is there anything else you would like to add before we close things out?
I just want to say thank you very much for this opportunity to share this message, but also extend a personal invitation to everybody who hears this podcast to come join us on our panel as we talk in more detail about this. We're pretty excited to share this new technology with you.
Yes, go to few.bbiconferences.com to see Chuck's two panels and his panelists, as well as the other ICM speakers that are featured on the agenda today. If you would like to hear more from Chuck regarding this presentation, his panel, Technologies Enabling Low Carbon Ethanol Production Throughout the Production Process 2, will take place at 3 p.m. on Tuesday, June 11th. Thank you again, Chuck, for joining us today, and we will see you at FEW very soon.
Thank you, Danielle.
And thank you to our listeners and FEW attendees. If you are interested in attending or learning more about the conference, again, you can visit few.bbiconferences.com for more information. Thank you for listening, and we will see you at FEW.